All right, so starting with example 2, thanks guys, we're gonna use the distance formula to find the equation of a sphere in 3D space. Thank you. So here's gonna be our equation. The center is HK and L, and that's just what they use instead of X, Y, and Z. Now this equation is really similar to what other equation? To the circle, okay, which makes sense because a sphere is a circle in 3 dimensions. Oh yeah, you can think of like the rotation of it. Okay, so we're going to find an equation of a sphere with a radius of 3 and a center of 6, -1, 2, and you guys did this on your own, so let's see how we did. So you should have x minus 6 squared plus y plus 1 squared plus z minus 2 squared equals 9, and the 9 comes from r squared. 3 squared is going to be 9, and then we plugged in each one of these. Notice that it does say the opposite, so when you look at it, if it's a positive 6, it will say minus 6 inside the parentheses. How'd we do? So far, so good? Okay, and then we started talking about example 3, and I told you that we are going to have to complete the square. So that's exactly what we're going to do for this, is complete the square. So we're just going to start by organizing our terms together. And I know some of you already did this, so feel free to move on to B. Okay, so when I'm organizing my terms together, I'm going to have x squared minus 18x, and I'm going to put my plus blank space in there for the actual completing the square process, plus y squared plus 16y plus blank, plus z squared plus 6z plus blank. But then I still have this 54. Do you guys remember the first step you do when you're completing the square? Yeah, move the constant term over. So if I subtract 54 from both sides, this is going to equal negative 54. So really, I'm going to end up completing the square how many times? 3, right? So I just, underneath this, I put plus blank, plus blank, plus blank, because I'm going to end up adding all of those together. Okay, so Anuva, can you tell me how you fill in this blank space to complete the square here? Okay, good. So negative 18 over 2 would be? Yep. And then what's negative 9 squared, everybody? Everybody? Okay, good. So then we're going to add 81. And then Megan in this blank is going to be what? That's okay. Yep, so do half of your b value. So, yep, exactly. So 8 squared, which will be 64. So I'm going to write 8 squared here, and then 64 in my other one. And then, Logan, what's my last one going to be?
3 squared.
Yeah. And then I'll square it and put it on this side. Do you guys remember why I leave my values like this?
Because you have to then write it in
Yeah.
sphere form.
Well, what's that called? In what form?
Sphere.
I like sphere form.
In factor form, good, okay? And then, yes, it will be in sphere form. Okay, so then that way when I factor that, I don't even have to think about it, okay? I'm just dropping this in, and that way I make sure I keep my right sign. So I really like that. Okay, and then we get that it is equal to 100 is what we should have. An easy way to do this in your head is 64 minus 54 would be 10, right? And then 81 and 9 would be 90. 90 and 10 would be 100. And so what we're going to do is we're going to write our equation, but then it also says find the center and find the radius. Okay, so Lauren, what's our radius going to be of this? Okay, good. How do you know? Perfect. Take the square root of 100, that'll be 10. And then Jonathan, what's our center going to be?
It's going to be 9, comma, negative 8, comma, negative 3.
Perfect. Okay, good. So your center is 9, -8, -3, and then your R value is going to be 10. Okay, do you guys think you can do part B without me? Let's give it a try. Let's give it the old college try. Yep, and you can just leave your radius as an exact value. Okay, and then Lydia, do you want to tell me what you got for your equation?
X minus 3 squared plus y squared plus z plus 1 squared equals 10.
Okay, great. Okay, so when we filled in the blank spaces, you should have -3 squared, so you're adding 9 to both sides. The y, since y is by itself, you don't have to worry about completing the square because there's no b value, so half of 0 would be 0. And then you're going to add 1 over for the 1 squared. Okay, and then your center should be 3, 0, -1, and your radius will be the square root of 10. What questions do you guys have for me on this one? We're good? Okay, then let's go to example 4. Okay, and reading through example 4, Emily, what does it say we're trying to find?
The trace of the sphere?
Yes, so we're going to find the trace of the sphere. So let's talk about what the trace of the sphere is. So I'm just going to show you a picture from the textbook real quick. So when you guys studied conic sections, what they would look like if you had a piece of paper going through the conic section. Okay, so this is what the trace of a sphere is. Think of this blue shade as a plane, and if a plane is going through the sphere, look at what's left. What shape can we see here? The circle. So the trace of a sphere is always going to be a circle. And that's true because if you think of a sphere, like I have this one, it's broken, so don't mind that. It has a little crack in it. But if I were to cut this in half, right? If I were to cut it in half, this would be my trace. Okay, so your trace is always going to be a circle. Even if it wasn't cut in half, no matter where I slice this, I would always be left with a circle as my trace. Okay, so that's what we're finding for each of the next problems. So we're going to start, it gives us our equation of the sphere, and then we want to know what the trace of the sphere would be in the xy plane. Okay, so remember from yesterday how we had the different walls. So if it was an xy plane, this was your z, here's your x, here's your y. So the xy plane would be the floor. Okay, so it would be like if we cut our sphere from the xy plane right there. Now, if we cut that in the xy plane, the z value would be 0. Okay, because this is the xy plane here, right? If I shade that in, okay, so your z value is at 0. We're thinking of that in 3 dimensions. So if z is going to be 0, I'm going to plug that in and I'm going to evaluate. Okay, so in the xy plane, my z value is 0. So into my equation, I'm going to plug in my z value is 0. and then I'm going to go ahead and evaluate. So remember that we already talked about how our trace is going to be a circle, so your equation should be, yeah, an equation of a circle. Okay, so if we have 0 minus 3 squared, we have negative 3 squared, which is what? 9. And what are we going to do with 9? Subtract it from both sides. Okay, and then I'm going to show you how to write your answer for this. On your test, it'll be like specific so you can remember what to do for everything. But that's a semicolon, not a J, just so you know, because we're going to have more. Okay, so in describing the trace of the sphere, you want to have your equation and what your other value is. So for the trace of the sphere, it's going to be this circle equation where your z value is 0. And you're going to identify the shape. So the shape is going to be a circle, and it'll always be a circle, with a radius of 4. And we get 4 from the square root of 16 is 4. And this is in the xy plane. And then you're going to tell me where it's centered. Okay, so the center would be 6, negative 3. And then we plugged in 0 for z. So that's going to be our value for z, or our value for L in the center. Okay, so let's try B. So B is in the xz plane. Okay, so B is going to be in the xz plane. And then Adam, if you had to make a guess, what do you think our first step would be?
Make y 0.
Good. Okay, so in the xz plane, it's your y value that's going to be 0.
That's just the one that's not there.
Yes. Okay, so if I do 0 plus 3, I'm just going to get 3. And then we're still going to subtract the 9 over. And then you guys can try C as well. Okay, so you guys should see if you can write down everything you need. So we can use this one as an example, right? So we have our equation, y equals 0. So is it still going to be a circle?
Yeah.
Yes. Okay, so the radius I need to find from this equation. So if it equals 16, how do I find the radius? Square root. And what's the square root of 16? 4. So it's still a circle with a radius of 4. This time it's in the xz plane, and the center is at 6, 0, 3. So you're going to get that from, this is your 6, this is your 3, this is your 0. Okay, and then let's try C. Or any questions on this one? Okay, so for C, they just tell you it's in the plane x equals 10. So what that means is this is going to consist of all of the points on the sphere whose x-coordinate is 10. Okay, so if we think about where that is on our picture, okay, if I have 10 out to here, it's going to be all of the points that are on 10, okay? So this side here, do you guys know what it's going to be parallel to? What plane this will be parallel to? Because it's all of these that are going to be 10, but it's going to be parallel to what plane?
X.
But the plane would be the what? Okay, yeah, the YZ. Okay, so it's going to be parallel to this here. Okay, and it's all of the points that are going to contain the 10. So now, instead of plugging in 0 for something, we know x is 10. So we're just going to plug in 10 for x. And then we can go ahead and evaluate. So 10 minus 6 is 4. 4 squared is going to be 16. What are we going to do with that 16? Yeah, subtract it from both sides. So we have y plus 3 squared plus z minus 3 squared equals 9. And that's when x is 10. And so this part is going to be a little bit different. So now it's still going to be a circle. The radius is 3, because you're going to square root the 9 to get 3. And then what we would say is that it's 10 units in front of the YZ plane. Because if you have your 10 here, it's going to be 10 units in front of that plane. And the center would be 10, negative 3, 3. Okay, so this is where you're getting your center from. This is where you're getting your radius from. And then, Anuba, did you have a question for me?
I was just I was confused on how you got the YZ plane.
Oh, for this one?
Yeah.
So it's just imagining this in 3D. So think of the room from yesterday. Okay, so if you were out on X, right, then it would be a wall that would be parallel with the wall of YZ. Does that help envisioning it like the walls? So it's like these would be the two sides of the room. So if instead it was on Z, right, if instead of X equals a value, if it was Z, then what plane is going to be parallel with the Z values? Yeah, the XY. And then the plane that's going to be parallel with the Y values would be? XZ. Because think about if you have this point out here, that's going to be another wall that's going to be parallel to this wall.
So why'd you say in front? Oh, okay.
Just because it's positive, yeah. And if it was negative, it would be behind. Okay, good. All right, so for example 5, we're going to apply this to a water tank that is in the shape of a sphere, and it has a radius of 5 feet. And it says the tank is supported on a metal circle 4 feet below the center of the sphere as shown in the figure. Find the radius of the metal circle. Okay, so you guys have your picture here. Okay, and this is our sphere. Okay, now it tells you that we're trying to find the radius of the metal circle. So this is the metal circle that we are trying to find the radius of. So we're trying to find this value here, this R value, okay? In order to do that, we have to know the equation of this circle, which would be a what? Of the sphere. A trace of the sphere, right? Because can you guys see how that's similar to what the picture I was showing you before in your textbook? If I were to take a piece of paper and cut my sphere, it would be in the shape of this circle where the metal ring is. Now, let's just do an equation for this sphere. So your center, you can think of the center is at 0, 0, 0. And then your radius would be 5, because that's labeled for you and given. So if I'm going to put this into a spherical equation, then I would have x squared plus y squared plus z squared equals 25. Okay, so my center is at 0, 0, 0. We're going to put it at the origin. Your radius is going to be 5. So this is our equation of the sphere. Now, it says that the metal circle is 4 feet below. So they're saying that this length here is 4 feet below, which means we know one of our values. Does anybody think they know what it is?
Wouldn't that be negative z?
It'd be, yeah, it would be the z value, and the z value would be negative because it's going down from the origin, and it would be negative what? It'd be negative 4. Why? Because they tell you it's 4 feet below, right? Okay, so if it's 4 feet below the center of the sphere, the z value is going to be negative 4. So we're going to substitute that into our equation. Okay. Ignore my rough drawing there. But here's your center. Okay, and then if it's 4 feet below, what we're saying is negative 4 would be this value. And we know that would be the z because you can think of this on the coordinate as your z value, right? That would be your z, this would be your x, this would be your y. Okay, so then when I plug in negative 4 for z, I'm going to get 16, so I'm going to subtract that from both sides. And then this is going to be the equation that represents the metal circle. Okay, so this is my equation for the metal circle. What is the radius of that circle? Yep. Yep, and how do you know?
Because it's equal to r squared.
Good, okay, so r squared equals 9, so you're going to take the square root. The square root of 9 is going to be 3, so that would be the radius of your circle. So this represents the equation of the metal circle, which is a trace. And then you have your radius. Okay, and I'm going to give you the rest of the time to work on your homework.